we get a boundary of operation like this. So, I will not show the second quadrant and the third quadrant, I will just show the first and fourth quadrant. So, I have VD, I have ID. So, what you need to do for getting the characteristics is assume some value of psi naught. So, I would suggest take the value of psi naught as 15 degrees. Mark some points A, B, C, D, E, F, G, H. So, here AB is a straight line segment. With slope -1. Then BC is a part of an ellipse. CD is a straight line segment. With slope -3. Then EF is a straight line segment. With slope +1. Then FG is part of an ellipse. GH is another straight line segment with slope 1. And HD is straight line segment with slope 3. So, what I am trying to say is I am trying to show this boundary of region of operation. So, the operation is restricted to this region in the first and fourth quadrants if I choose the value of psi naught as 15 degrees. So, I take the value of psi naught as 15 degrees and get this region. So, essentially this AB, I mean I should be able to guess what is AB then. AB is corresponding to constant alpha or constant gamma or constant U. Constant alpha. So, it is corresponding to one particular value of alpha. Any guess what will be the value of alpha? Say, see this ABCD EFGH is a curve which gives the boundary of operation. Operation is not possible beyond this. See what I like. This is the region of operation which is possible. Yeah. Alpha is 0. So it actually corresponds to alpha equal to 0. Then if I take BC, okay, it may not be very obvious why what is this correspond to. I will give the answer. U equal to 60 degrees. It's part of an ellipse corresponding to U equal to 60 degrees. Then if you take CD, so this is constant alpha, constant gamma, constant U, constant gamma. See, constant gamma will always give positive slope, whether it is 2 and 3 valve conduction mode or 3 and 4 valve conduction. So this is constant alpha, and this corresponds to alpha equal to 30 degrees. So here U is greater than or equal to 60 degrees. See, I didn't say what is the value of U for AB. Is it obvious? What is the value of U for, what is the range of U for AB, line AB? Since alpha is 0, it can't be greater than, U can't be greater than 60 degrees. So U is less than 60 degrees for AB. Then if I take the straight line segment EF, so EF is a straight line segment with positive slope, so it corresponds to constant gamma. So it actually corresponds to gamma equal to psi naught, which I have taken the values, which I have taken to be equal to 50. So this is for U less than 60 degrees. Then if you take FG, so I said FG is an ellipse, so that means it corresponds to constant U. So this corresponds to U equal to 60 minus psi naught. Then GH is again a straight line with slope 1. So it corresponds to constant gamma. So it actually is corresponding to alpha, gamma equal to 45 degrees, and U is less than or equal to 60 degrees. And finally HD. See, whenever the slope of the straight line segment is 1 or minus 1, it corresponds to constant gamma or constant alpha. The value of U is less than or equal to 60. Whenever the slope of the straight line segment is plus 3 or minus 3, it is plus 3 for constant gamma and minus 3 for constant alpha. U is greater than 60 degrees. So HD corresponds to gamma equal to 45 degrees, but U is greater than or equal to 60 degrees. Now, if I want the point in, see, what is the first quadrant? First quadrant corresponds to positive VD, that means rectifier operation. So if I take rectifier operation, then which point corresponds to maximum power? I mean, if not which point, can I restrict myself to some region? Say, let me take this region. Okay. So this is rectifier, allowed rectifier region. So if I want the point of maximum power, exact point may not be easy, but can I say that it lies on some curve? Which curve? ABC. Yeah, it lies on the ABC D curve. So it can be shown that, I will leave it to you to prove that it lies on the BC curve. So there is one point on the BC curve. Suppose I call this as I. So prove that the maximum power. So this I corresponds to maximum power as rectifier. So I will leave it to you to prove that. See, what you need to do is along AB try to see what is, if I take along AB, then can I say which point is correspond to maximum power along AB?
If it is on BC, the maximum power, then
Yeah.
along AB, the maximum power will be on BC.
B. See, if I already given the answer as on BC, along AB it is B. So since the answer is along BC, if you take CD, along CD it is C. Along CD it is C. Okay. So, but one has to prove that. Similarly, if I take inverter operation, so inverter operation is corresponding to this region in the fourth quadrant. So in the fourth quadrant, again, the maximum power point has to lie on this curve EFGH. So again, one can show that it lies on this curve Fg. Suppose I call it as J. So this corresponds to maximum power as inverter. See, please note the two are different. This is maximum power as rectifier when operating as rectifier, whereas this is maximum power as inverter. So what I would suggest is to take all this. I have mentioned so many points here, A, B, C, D, up to J. So you take all these points. So if I take point A, B, C, D. A, B, C, and D corresponds to rectifier operation. I also corresponds to rectifier operation. I is correspond to maximum power as rectifier. Then E, F, G, H. These are all in E, F, G, H lie in the fourth quadrant. So they correspond to inverter operation. J is also inverter operation. So what I would suggest is try to get the values of alpha, gamma, U, ID and VD. For these points. So fill this table. That's essentially filling this table.